The intermediate value theorem states that a continuous function will not skip y values. So that can explain theorem 1. So theorem 1 states that if f of x is continuous on a closed interval from a to b, then f of a does not equal f of b, which means it has a slope. Then for each value of m on the y-axis between f of a and f of b, there is at least one value of c on a, b, where f of c equals m. So shown here on the graph, this is f of a, and this would be f of b, just down here. So between a and b, there has to be a value of c where m is going to be. So if we say that m is here, just above f of b, then there is this value of c, because on this entire graph, it has to be continuous. So IVT states that on this continuous line, there always has to be a value of c where m will be on it if m is between f of a and f of b. So continuing this, we can also use IVT to show the existence of zeros on a function. If, say, f of a was greater than f of b, then IVT guarantees that f of c equals 0 for c on a in between a and b. So if f of x is continuous on a and b, and f of a and f of b are non-zero and have opposite signs, then f of x must have a 0 between a and b, because if they are opposite signs, that means at some point it must cross the x-axis, and at that point in between a and b would be a 0. So now we're going to do some practice examples using intermediate value theorem and corollary 2. So the first states use IVT to show that f of x equals x cubed plus x takes on a value of 9 for some x in 1 and 2. So first we can test out what the values of 1 and 2 are to see if 9 will fall between those two y values. So f of 1 equals 1 plus 1, which equals 2, and f of 2 equals 2 cubed, which is 8, plus 2 equals 10. So because 9 is in between 2 and 10, that means that IVT supports the fact that 9 will be on some x on 1 and 2. So the second example is use IVT to find an interval of length of a half containing a root of f of x for f of x of x cubed plus 2x plus 1. So first we have to recognize that we can use corollary 2 to prove this, since corollary 2 states that if f of x is continuous on a, b, then f of a and f of b, when they are non-zero and have opposite signs, f of x must have a 0 between a and b. So we have to find an interval of length of a half, which will have opposite y value signs, which means that there will be a root in between those two x values. So first we must find probably the easiest x value to plug in at first would be f of 0, which 0 cubed is 0, 2 times 0 is 0, plus 1. So f of 0 is 1, and then we can start going down by a half, because this is a positive value and we want to find something that has a negative value for y. And because we need to have the length of a half, let's go down by a half, so negative a half. If we plug negative a half into it, that would be negative 1 over 8. So that's in the negative y, and then this has a positive y. So then because they have opposite y value signs, then corollary 2 does guarantee that f has a root on negative a half and 0. And the third and final example So the third example asks to draw a graph with jump discontinuity at x equals 2, but satisfying the conclusions of IVT on 0, 4, which means that for every x value, there has to be a valid y value that can be found on the graph. So just jump discontinuity means that the limit of the two functions from left and right are not equal. Oops. So here are two functions that are not equal when the limit is approaching 2, and then to satisfy IVT we can put a point in the middle of them or wherever so that f of 2 does actually have an answer. So this will satisfy the intermediate value theorem because there will be a y value for each x value plugged in, and it does have jump discontinuity at x equals 2.